Alright, here's a video on the molecular geometry part. So last time we talked about linear geometry, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral, and how they utilize the electron domains from the Lewis structures in the valence shell electrons. So for linear, there's 1 or 2 valence shell electrons. For trigonal planar, there's 3. Tetrahedral, there's 4. Trigonal bipyramidal, there's 5. And octahedral, there's 6. So let's just kind of break down kind of what we're talking about here. A is going to, let me zoom in here. A is going to stand for the central atom, while X is going to stand for the bonded atom, and then E is going to stand for the electron domain. So again, similar words, different usage form. So for a linear, A bonds to X, we have a molecule, or A bonds to 2 X's, and this is what we consider a linear geometry. Same words, 2 different contexts. This is for a molecule, even though Vesper linear refers to the central atom, molecular geometry refers to the molecule. Why do we use the same words for 2 different things? Because it's chemistry, and we just want to confuse high school chemistry students. I don't know. I wish we would find better words, but they are literally the same shapes. So for linear, we have 2 atoms, or 3 atoms, all bonded in a line. Let's see here. Now if we have X bonded, or A bonded to 3 X's, this is what we consider a trigonal planar geometry. It's a triangle in the same plane. If we remove an X, or we have one less X, a bonded atom, we end up having an electron domain, or a lone pair, bonded to X. It's terrible. And this is what we consider a bent structure. For an example, SO2 has these 2 bonded here, double bond here. We have some extra valence electrons on the oxygens. And this is considered a bent geometry. It's from the trigonal planar family, but we lost one of the potential bonds. So we still have, and this is where it's going to get confusing, if we count the electron domains of the central atom, we have 1, 2, 3, and they're all negative, and they're all going to repel each other the same way those 3 balloons repelled each other. So we're going to have this fashion. Even though there's no bond here, it's a lone pair, it's still an electron domain, and it's going to push away and repel those highly negative double bonds. So this is how we stay in a trigonal planar versus this. This is linear. That's wrong. That's not what we're referring to. What happens because of these extra lone pairs, it pushes and repels these away, forcing it into a bent geometry. Trigonal planar, 3 electron domains. If it loses 1, it's bent. All right, let's go to another one. If we have X, we have 4 bonded atoms to 1 central atom. We refer to this as a tetrahedral. Tetrahedral. Remember, this is our classic carbon geometry. If you see carbon, most likely it'll be this. Now, what if we remove an X? We'll be left with only 3 instead of 4. So but we will have an electron domain. And because this is highly negative, it's going to repel the other atoms away. This is what we consider trigonal, because of the pyramid on the bottom, pyramidal. So we have trigonal pyramidal because A is higher above the X's that are below it because of this electron domain repel. It pushes those electrons down, forcing a pyramid shape. Trigonal pyramidal is if tetrahedral removes removes a bonded atom, and if we remove another bonded atom, if we remove another bonded atom, we'll be left with A having 2 electron domains, and then we'll have 2 X's. Now this is also considered bent. Why do we have the same word for 2 different things? I don't know. Ask the chemistry gods. But you can imagine that we have 2 lone pairs here. They're going to repel each other, and they're going to repel the 2 bonds in this atom. So if we start with 4 electron domains, and we have 2 lone electron pairs, only 2 bonded atoms, it's a bent structure. If tetrahedral, which has 4 electron domains, loses 1 bonded atom, is considered trigonal pyramidal. If it loses 2 bonded atoms, it's considered bent. So take a moment to look at this family, this category. It's pretty much if we take the original, we lose 1, now it's a triangle pyramid, trigonal pyramidal. If we lose 2, now it's going to be bent. That is the progression that you need to learn. Each family, each Vesper family has a few others that can be created from it. If we back up a second, if we take our trigonal planar and we remove one of the bonded electrons, now we have a bent structure. If we remove another one, well, now we just have linear. So that is the pattern. That's the logic behind this entire geometry system, is starting with the Vesper, remove one of the electron domains, and seeing what happens. I know it gets confusing. It does just take practice. So let's do one more, and we'll go from there. So what if we start with trigonal bipyramidal? So remember, we have a triangle, and we have a bipyramidal, which means we have a pyramid on top and a pyramid on bottom. So just to show the geometry, there's our triangle pyramid, and here's our second pyramid. Trigonal bipyramidal. 2 pyramids. So, if we remove an X, what will we be left with? We'll have A bonded to X. Remember, the dark ones are coming out toward you, and the dotted lines are going away from the screen. Here's our electron domain. It pushes away and repels the bonds and the bonded atoms, and because of that, it creates a seesaw motif. And to draw the seesaw, I'll show you in gray. Here is the seesaw that's going to be on the ground, and then here is the thing that you stand on. So here's person 1, and here's like person 2, and they tilt this way on the seesaw. And then these two, because they're facing a perpendicular to the blue, that's what it tilts on. So I really want to challenge you, take the gumdrops, take the toothpicks, figure out how to make this, and you'll definitely see the seesaw shape. But remember how we got there, we started with the trigonal pyramidal, and we took off one of the electron domains, one of the bonded atoms. Now if we take off another one, we remove an X, we'll be left with a really funky one. We'll have 2 electron domains here, and then we'll have these 3. But if we look closely, these electron domains are going to repel each other and repel equally the bonded atoms, forcing literally we'll be forcing into a T. This is considered T-shaped. So take a look. We started with 5 in trigonal bipyramidal. We removed one X and we got seesaw. We remove 2 X's and we get a T-shaped. Now if we take trigonal bipyramidal and we remove 3 X's, ooh, that's a lot. What's going to happen? Well, we end up having A in the middle. We have an electron domain here, electron domain here, electron domain down here. Then we have our 2 bonds. What shape is this? Well, this goes back to linear. These electron domains are going to repel equally upwards. These ones are going to repel equally downwards. It's going to force X's into the same line. So this is linear. Why? Okay, so class, here is here's the picture of the octahedral family. I don't want to make this video too longer than 15 minutes. But if we start with our octahedral 8-face family, we remove an X, we end up with square pyramidal. That's literally the square in a pyramid. Alright, because our electron domain at the bottom pushes everything upwards. And if we remove 2 X's, we end up having this square planar geometry where we have an electron domain on top and on bottom, like those 2 balloons, with a square in the middle. So that's our square planar geometry. And then a classic example of that is xenon fluoride. Xenon tetrafluoride. We have 4 fluorines bonded to 1 xenon, and we have an expanded octet. So remember, expanded octets are important. They usually come with the halogens, and they're usually really, really big molecules. But yeah, so here's our family for octahedral that I need you to know. If you have questions on this, it's okay. This is really hard stuff. It's rare, very rare do kids on the first time learning this really understand all of it. If you do, excellent, you're ahead of the curve. But if you don't feel bad. It takes years to learn chemistry. It's very intricate and very complicated. The best thing you need to do now is just go through the textbook, sections 9.1 to 9.4, and they does a really good job of describing how this works, what happens, how it's supposed to happen. And then from there, study the study guide that we posted, answer some of the questions, and use the models, and do that. Okay, email me if you have questions, and we'll talk about it later. Have a good day.